given that dy by dx is equal to xy, so this is the one equation, and dz by dx is equal to xy, and this is the boundary condition for first equation, and this is the boundary condition for second equation. So how do you come to know that this is belongs to first and this belongs to second? See here, this is the y. So therefore this belongs to first, and here it is z, and here also z. So likewise you can correlate, even they may give mixing first z of 0 is equal to 1 and y0 is equal to 1 later on. So in that case you have to identify which one is belongs to which equation. So based on this function. Okay, and here h is given, h is equal to 0.01. Use Runge-Kutta second order method to find the values of y and z at x is equal to 0.2. So this is the problem. So for this, so we have to find the solution. So in the solution, first of all, what we have to do, so we have to understand the boundary conditions. So first of all, Runge-Kutta second order method equation. So this equation is for second order RK method. So first of all, we have to find the K1. K1 is equal to h into f of x naught y naught, and K1 is equal to h into f of x naught plus h plus y naught plus k, and k is equal to half into K1 plus K2. So this is the equation for now here. So first of all, we have to understand the boundary conditions. So these are the two boundary conditions given. Y at x naught is equal to 1. So this meaning already is we have understood in the previous lecture. So the value of x naught, see here, you relate this y0 is equal to 1. This is the given condition. So now you relate this. What is the value of x naught? X naught is equal to 0, and so this is the y naught. So otherwise I will write, okay, 1. This is y naught is equal to 1. Now in this case, so here this is x naught and here it is y naught, just you remember. So one for this is for first equation. Similarly, you can write for a second equation. Second equation also, x naught is equal to 0 and z naught is equal to 1. So next what we have to do, so we have to determine number of iterations. So here number of iterations xg. So this xg is given, xg is equal to 0.2 minus x naught. X naught is 0. So here you can see in the both the cases it is 0. So always you will get this equation such that the x1 x naught for both the cases is same. So therefore you need not to worry. So which one is to be taken? In both the cases you will get the same x naught value. Xg minus x naught upon h is equal to 0.2 minus 0 upon 0.1. So you will get 2. So here number of iterations 2. So once you come to know that what are the number of equations, boundary conditions, and what is the equation for computing new value, so that equation I will write here. I think that is not written. Y1 is equal to y naught plus K1 plus K2 by 2. So this equation, so we have learned in the previous slide. See here, what is the equation here? So y1 is equal to y naught plus K1 plus K2 by 2. Same equation. So we have to use here to find the new value. So this is for y equation. So there is a one more equation, z equation. Z1 is equal to z naught plus K1 plus K2 by 2. So here we have to use simultaneously two equations for computation of K1 and K2. So this is common for both the equations, these three equations. That's why I have written the whichever is common for both the equations here. And these are the two simultaneous equations we have to use. So let us see how to go ahead with this problem. So first iteration, in first iteration, we know the values. X naught is 0, y1, y naught is equal to 1, z naught is equal to 1. So this we have extracted from the boundary conditions. And then apply a second order RK method. There are two functions, hence we have to deal with two set of equations simultaneously. So first of all, I will take for first equation. So the given equation dy by dx is equal to f of x naught y naught. So this equation is given in the numerical. So you can see the problem. See, this is the equation. Dy by dx is equal to y into z. Dz by dx is equal to x into y. Just you remember these two equations. Okay, let us start with first equation. So this is the given equation. So right here. So this is given. So I have written given into a desired form. And next, so what is K1? K1 is equal to h into f of x naught y naught. So that is equal to h. So what is f of x naught y naught? So this is f of x naught is equal to y naught into z naught, y naught into z naught. Same thing I have written. So similarly, next K1 is equal to, so this is not K1, K2 is equal to h into f of x naught plus h into y naught plus K1. Now, first of all, we have to find what is the value of this K1. So value of K1, h is equal to, what is the h value? So here from the problem, so we have to take from the previous. H is equal to 0.1. So it is given. H is equal to 0.1. So this is 0.1. This is also you have to write first. So this is 0.1 into y naught and z naught. Y naught value is 1 into z naught value is 1. Directly you substitute here. 1 into 1, 1. So this is equal to 0.1. K1 is equal to 0.1. Now you find K2 value. K2 is equal to h into x naught plus h, y naught plus K1. Now, so here function of x naught, what is the value of x naught? X naught value is 0 plus h value is 0.1. So here you will get, this is, I will write here 0, 1, comma. So y naught value is 1 and K1 value is 0.1. Now you can write this as h is a function of, so this is 0 plus 1, it is 1, comma 1.1. Now simply what we have to do, so we know this, and what is the function? So you can write this is equivalent to given function h into.
Hello, sir.
Yes.
Sir, h 0.1 है ना? x naught plus h.
X naught plus h. 0.1. Sorry. So this is not 1, 0.1. This is 0.1. Okay. 0.1, comma 1.1. So now here we know h is a function of, I will write this 0.1, comma 1.1. Now this is equivalent to, so this is equivalent to, I will write in some other color. So this is a given function now. So given function is, so h remains as it is. So f of this, it is in the form of function of y naught into z naught. So y naught into z naught. So this is not function. So y naught into z naught. Function of this into, you write in this form because this is the original equation. And this is f of x naught y naught. This is not a x naught y naught. This is y naught and z naught. So y naught z naught. So function of y naught and z naught. So h into y naught into z naught. This is the given equation. So here y naught into z naught. Okay. So this you can write. So I will make comma, and this you can write. This is h. So this is equal to y naught into z naught. So in bracket I'll write y naught into z naught. Now what is the value of y naught and z naught? Here this is the y naught value and this is z naught value. So you substitute simply h is equal to 0.1 into y naught value is 0.1, 0.1 into z naught is 1.1. So 1.1 into 0.1, 0.111 into 0.1. So this will be 0.0111. Am I right? This is or 0.111. How much it is?
0.0111.
Is it right? Whatever I have written?
Only two times 1, sir. Only 2 times 1.
Huh?
2.
Yeah. Okay. So this is equal to 0.011. Okay. Now once we got K1 and K2, next step what we have to do? So we have to find the K value. So this K is equal to half into K1. K1 value is 0.1, 0.1 plus K2 is equal to 0.011. So by 2, how much it is? See anyone? 0.1 plus 0.011 equals this divided by 2 is equal to 0.055. 0.0555. Okay, so once you got K, so what is the next step? So similarly we have to find for second function. So second function here dz by dx is equal to x naught into z naught. Okay, it is a function of x naught into z naught. Both I have written here. So this is equal to, from the equation it is given x naught into y naught. So next equation, so we have to find, instead of taking K1, so because this is another equation, I have written here it has a L1. L1 is equal to h into f of x naught z naught is equal to h into x naught. Directly I have substituted here. So in place of this, so now you substitute the values. H value is 0.1 into x naught value is 0 into y naught value, it is 1. 0 into 1, entire equation becomes 0. Now similarly we have to find out L2. L2 is equal to, so here x naught value is 0 and h value is 0.1 and y naught value is 1 and L1 value is 0. Now here this is in the form of function f of, first of all we have to calculate 0.1 comma 1. So this is the function. So you can write this in the form of above equation x naught y naught. So I will write h into x naught y naught. So this is equal to h is equal to 0.1 into x naught value is 0 into y naught value. So this is y naught value is 1. So this is equal to again 0. So here
No, sir,
L1
x naught is equal to 0.1, no?
x naught is equal to
0.1 in L2.
in L2 x naught is equal to 0.1.
1.
Yeah, x naught is equal to here. Yeah, sorry. So this is the equation as it is. We have to take this is 0.1. 0.1 into 1 is 0.1. Oh, okay. Again, you will get 0.011. Am I right? Is it right? 0.1 into 0.11 is equal to 0.011. Okay. So we got 0.100. So once you got L1, L2, similarly you compute here L. So I think I have written equation. L is equal to half into L1 value is 0 plus 0.011. So this is also you will get 0.0555. Now update the values. Now we are going for second iteration. So in the second iteration, so we have to update the values. So here for updating value, x naught is equal to x naught plus h. So x naught plus h is, so this is 0 plus h 0.1 is equal to 0.1. And next y naught value, y naught is equal to y naught plus k. Y naught value is 1, k value is 0.0555. So that is equal to 1.0555. And next z naught value is, z naught is equal to 1 plus L 0.0555. So that is equal to 1.0555. And y naught value is equal to 1.0555, and x naught value is same. Now once you got this new value, so now we have to start with new iteration. For new second iteration, the second iteration, so we have to check the value of x naught. So what is the value of x naught? X naught is equal to x naught plus h. So this is equal to 0.1. Y naught is equal to 1.0555. Z naught is equal to 1.0555. So we have carried out. So here the values from previous iteration, h is equal to 0.1. Is it okay? So we have taken all the values. X naught is equal to 0.1, y naught is equal to 1.0, and z naught is equal to 1.0555. Okay. So we have written all the values for second iteration. So apply second RK method. So there are two functions. So same way. So we have to deal with the second function. So same value. So now I will write directly. So what is the value of h? H is equal to 0.1 into y naught value. Directly you put y naught value 1.0555 into z naught value. Z naught value is also 1.0555. So you simplify this, so you will get some value. So its value is 1.0555 into 1.0555 into 0.1 is equal to, so this is 0.4 times 1.4. 4 times 1, 3 times 1.4. Okay. So this is the value of K1. Similarly, so we have to find the value of K2. K2 is equal to x naught plus h. So x naught plus h is, x naught is 0.1. 0.1 plus 0.1. Otherwise, I will write in detail. 0.1 plus 0.1. So this is h into f of 0.2. Sorry. And here second term, So is y naught plus k. Y naught value is 1.0555 plus k1. K1 is 0.1114. So on adding this, so you will get 1.1669, isn't it? Now you find the value. So here h value is 0.1 into y naught value. So this is y naught value. Y naught value is 0.2 and z naught value is equal to into 1.1669. So on simplification, so you will get 0.1 into 0.2 into 1.1669. So this is equal to 0. Just the verify, cross verify the values, whatever I am writing here. So 0.0233. So we got K1 and K2. So this is K2. So then finally you compute this value K. So this is half into K1, 0.114114 plus K2 is equal to 0.02333, and this is equal to this 0.1114 equals divided by 2 equals 0.0674. 0.0674. This is 0. Now we got the k values. Similarly, we have to find the L1 and L2 or L value. So here you substitute the values directly. So h is equal to 0.1. So x naught value. So x naught is equal to 0.1 into y naught value. Y naught value is 1.0555. So multiply these three on multiplication. So you will get, so 0.1 into 0.1 into 1.0555. So you will get 0.01055. Okay. So next, similarly, so first of all, we have to find the function x naught plus h. X naught value is 0.1 and 0.1, this is 0.1, and y naught value is, again, this is 1.0555, and L1 value is 0.0105. So on simplification, h is a function of, this is 0.2 and 1 point, first is 0, 5166566, you will get 0. Okay, so this is the value. So directly you substitute. So in the above equation, so h value is 0.1 and this is, so x naught value is 0.2 into y naught value is 1.066. So on simplification, so you will get L2 value. So that is 0.1 into 0.2 into 1.066 is equal to, so here you will get 0.02132 plus 0.010555 equals divided by 2 equals. Now we have to find similarly L1 value next. Sorry, L value. So for computing L value, so this is equal to half into L1 value 0.0114 0.0555 plus L2 value is 0.02132. So divided by 2. So on simplification, you will get 0.015937 something. So once you know the L value and K value, so we have to find the next, update the values. So again, update the values of x naught. So x naught is equal to x naught plus h. So right now x naught value is 0.1, h is 0.1. So this is equal to 0.2. And next y naught value, y naught value is equal to, so this y naught value is 1.0555 plus k value is 0.0674. So this is equal to something. Okay, we will compute. So next, so okay, plus 0.0555. So now you compute this z naught value. Z naught value is equal to 1.0555 plus 0.159375. So this is equal to 1.071435. And similarly, you compute this previous value 1.0555 plus 0.0674. So this is equal to 1.1229. So likewise, so we will get the values of x naught, updated value, y naught, and z naught. So these values are used for further iteration. But in our case, so what we have computed, so we need to compute only up to 2 iterations. So therefore, so we have to stop here itself. So we have to update the values and we have to stop the iteration here itself. So anybody is having any doubt relevant to this? Hello? Hello? So this is so simple. Only thing is you have to be careful about the values to be substituted. So you go in little bit in details. So then there is no harm here. So it's a very simple method. This is a simultaneous. Both equations we have to solve simultaneously. And first iteration as well as second iteration, third iteration, and fourth iteration, so on. So I have presented this in a very simplified form. So now, so we have to think of algorithm. So already you are familiar with this procedure. Just you remember any one procedure. So any one. So just you remember this. So you can write the algorithm and program for this method.